NASA is attempting to physically push a dead satellite into a higher orbit using a robotic spacecraft, something that has never been successfully done before. And if it works, it will permanently change how humanity manages the growing crisis above our heads. The satellite at the center of this mission is the Landsat 7 Earth observation spacecraft, which has been orbiting Earth since its launch in April 1999. For over 2 decades, Landsat 7 delivered irreplaceable data about Earth's changing surface, tracking glacier retreat, deforestation patterns, agricultural shifts, and urban expansion across every continent. Its instruments have contributed to thousands of scientific studies and informed policy decisions affecting millions of people. But Landsat 7 is running out of the fuel it needs to maintain its operational orbit, and without intervention, it will eventually drift into an uncontrolled decay that ends its mission permanently. NASA's response to this problem is the OSAM-1 mission, On-Orbit Servicing, Assembly, and Manufacturing. Originally conceived as a robotic spacecraft capable of approaching, grasping, refueling, and repositioning satellites not originally designed to be serviced, OSAM-1 represents the most ambitious attempt ever made to develop a universal space servicing capability. The core technical challenge it addresses is profound. The vast majority of satellites currently in orbit were designed and launched with zero provision for any kind of external servicing. They have no standardized docking ports, no accessible fuel valves, and no built-in mechanism for another spacecraft to grab them safely. What OSAM-1 is being engineered to do is essentially perform mechanical surgery on a patient that was never designed to receive it. The robotic spacecraft carries specialized tools capable of penetrating a non-cooperative satellite's existing fuel lines and injecting new propellant, a process that requires extraordinary precision at orbital velocities of approximately 7.8 kilometers per second. One wrong movement, one miscalculated approach vector, and the target satellite could be damaged beyond recovery or sent tumbling into an uncontrollable spin. The technology being developed for this mission did not exist in operational form before OSAM-1's development program began. Engineers had to invent new robotic end effectors, the mechanical hands at the tip of the robotic arm, capable of gripping satellite structures that were never intended to be gripped. They developed new proximity operations software, allowing the servicing spacecraft to safely approach and station keep beside a non-maneuvering target. They created new fluid transfer systems capable of moving hydrazine propellant between spacecraft in the thermal extremes of low Earth orbit, where temperatures swing from positive 120 to negative 160 degrees Celsius across each 90-minute orbital period. The economic argument for making this technology work is enormous. There are currently thousands of satellites in Earth orbit representing hundreds of billions of dollars in combined hardware investment. The majority of satellite missions end not because the spacecraft's instruments have failed or its electronics have degraded beyond usefulness. They end because the satellite runs out of fuel for orbital maintenance and attitude control. A spacecraft that cost $500 million to build and launch, that could continue functioning scientifically for another decade, is instead deorbited or left to drift simply because its propellant tank is empty. OSAM-1 is the first serious attempt to solve that problem at a robotic, scalable level. The mission has faced documented challenges. NASA's Inspector General reports flagged significant cost growth and schedule delays throughout OSAM-1's development history, with program costs climbing well beyond original estimates. NASA conducted internal reviews examining the program's path forward, reflecting the genuine engineering difficulty of what is being attempted. These are not failures of ambition. They are the expected friction of developing genuinely unprecedented technology that pushes against the boundaries of what robotic spacecraft have ever been asked to do. The broader ecosystem developing around on-orbit servicing reinforces why persisting through those challenges matters. Northrop Grumman's Mission Extension Vehicle program has already demonstrated that a spacecraft can dock with and extend the operational life of a geostationary communications satellite, completing successful docking operations with Intelsat satellites and providing propulsion assistance to extend their service lives by years. Astroscale, a Japanese commercial space company, has active missions in development and testing, targeting both debris removal and satellite life extension services. The industry is forming around the proof of concept, and OSAM-1 represents the most technically demanding demonstration within it. If NASA successfully uses OSAM-1 to push Landsat 7 into a higher graveyard orbit rather than allowing it to become uncontrolled debris, and if the refueling technology demonstrates even partial success, the downstream implications reshape the entire economics of the satellite industry. Insurance models change. Mission planning changes. The assumption that every satellite is a one-way expenditure gets replaced by a model where orbital assets can be maintained, repositioned, and extended the way terrestrial infrastructure is maintained, indefinitely, with the right servicing capability in place. The graveyard of stranded, fuel-depleted satellites currently orbiting Earth represents one of the most expensive infrastructure problems humanity has ever created and then ignored. NASA is now attempting to build the tow truck. So here is the question that matters beyond the engineering. If robotic on-orbit servicing becomes a standard capability, do you think it will primarily be used to extend the lives of scientific and government satellites, or do you think commercial operators will capture this technology and use it to build permanent orbital infrastructure that changes how business is done in space forever? Follow this page right now if you want every breakthrough in space technology covered clearly and completely, because the decisions being made in orbit right now are going to define what the next century of spaceflight looks like.